Start with the topics. Search green solvent for the future. The title of the topics today, that's search green solvent for the futures. It is title is like that. It is an audacity. I'm not giving you order. This is my suggestion to all of you. As you are in chemistry teacher in colleges and universities, so I think this is a fruitful lecture, help to you in your different institute, and it is my suggestion, rather you can say, search green solvent for the futures. Okay, myself Amlendu. I am now emeritus scientist CSR working in Department of Chemistry, Kurukshetra University. Little bit I'll go brief introduction of the green chemistry. Let's start. That you know that green chemistry, that is an essential part of chemistry curriculum. The teaching of green chemistry in classroom, laboratory should be go simultaneously. In India,
sir,
although green chemistry is being taught in a few colleges and universities, laboratory experiment remain largely the same as being taught 50 years back. It's unfortunate, I'm telling. New education policy came. Let's see how much it will change, but we have to change our mentality. You have to change our mental setup. That is very important. I will give some of the suggestion to you. Let's see. Many of these experiments, what we do in our lab, toxic chemicals. That you know, liquid bromine, potassium cyanide, benzene, carbon tetrachloride. Most of the organic chemicals, they are toxic, either inflammable, either hazardous, everything, are not all safe to human health. So thus a need with safe green laboratory experiment is felt by the academic community. I'm telling green chemistry, some of the universities in India, they have put in the syllabus, either in college and universities also.
Professor Pal, sir.
So that is necessary nowadays.
Professor Pal, sir.
Anyway, next.
You not share a screen.
Sir,
kindly share a screen, Professor Pal.
Kindly share the screen, sir.
Green chemistry definition, if we say that green chemistry is the utilization of a set of principles that reduce or eliminate. Eliminate is not so possible, but we can say how much we can reduce. Use and generation of hazardous substances in the design, manufacture and application of chemical product. So that is very, very important. Green chemistry is about what we say in green chemistry, that is waste minimization at source, use of catalyst in place of reagent. Nowadays I will tell some of the example where green solvent used as catalyst in place of toxic chemicals or either inflammable chemicals or hazardous chemicals reagents. Using non-toxic reagents also we are using most of the times. Use renewable resources and improve atom efficiency in the sense the reactant, whatever the atom is there, product should be the same atoms. Otherwise, it will be some byproduct that will be wasted, that will go to the environment. Another is use of solvent-free, recyclable, environmentally benign solvent system. Solvent-free is not possible.
Sir,
that is true. But we can do recyclable, environmentally benign solvent. That solvent can be recycled. That will be better.
Sir, your PPT is not visible, sir.
Next. Green chemistry is about reducing the waste, reducing the materials, minimum materials you have to use, minimum waste product, byproduct comes, and hazardous also you have to reduce. Risk factor is also very important. Laboratory experiment. Hello.
Sir, your PPT is not visible, sir.
Now PPT is visible, I think. Okay, let's see. Let's see. I have because at the beginning that I have not read full picture. Now it is full
Yes.
picture.
Yes, sir.
Now it is
The
full picture. At the
PPT
beginning, 2 or 3 slides. I understood
Yes,
some
sir.
problems. Now it is visible. I think so.
Sir,
Whole picture is coming in the laptops.
sir,
So
but it is not
reducing
shared,
energy
sir.
also, this is
Sir, it
very
is not
important
visible,
also,
sir.
and cost effective also.
Sir, it is not shared with the
Cost
participants.
effective also. I will tell some of the things: how waste, material, hazards, risk factor, energy, cost. Green chemistry reduce all these things. Why do we need green chemistry? Chemistry is undeniably a very prominent part of our daily lives, that we know chemistry in daily life.
Excuse me,
Chemical
sir.
development
Can
also
you repeat
brings
that?
new environmental problems, harmful, unexpected side effects, which result in the need for greener chemical products. That you understand, जितना chemicals development होते जा रहा, environmental problem, harmful effect, side effect बढ़ते जा रहा. So we have to think. Hello, hello, हाँ हाँ hello, बताओ, हाँ. Yeah, but it is not. Okay, 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 okay. But I have to. Uh, so I have to go. Just a minute. I have to go. I have to off it.
Hello. Hello.
PPT sharing, sir. Start now.
Hello.
Yes, sir.
Dr.
Yes, sir.
Janaki.
Yes, sir. Yes, sir.
It is okay. It is okay.
Yes, sir.
Sir,
Now it is seen.
now it is okay, sir.
That's why I'm telling. Actually, problem is that your link is open in Google only, not Google Chrome.
Okay, sir.
Yes.
Okay, sir.
That's why I face the problem, because I have to again went to Google, not Google Chrome. Earlier it
Okay,
was
sir.
Google Chrome. That's why.
Okay, sir.
Now it is okay.
Okay.
I can
Yes,
start
sir.
from the
It is
beginning.
Yeah, yes, sir. Okay,
So
sir.
let's start. If any problem come, you can call me.
Okay, sir. Okay, sir.
Dr. Janki.
Sir, can you
Let's.
just, sir, just a
Okay.
minute. Can you click on that hide in your screen? Just click on that hide button. Just click on that hide button. Stop sharing and hide. Just click on hide.
Okay, okay. Yes.
Yes, sir.
I understood. Hide button. Is
Thank
it?
you, sir. Yes, sir. Thank you.
Yes, sir.
Okay.
Thank you, sir.
Now, okay, let's start with that. This is technical problem. Anyway, the title of my topic that I told you, that is the search green solvent for the futures. The title, it looks like that I'm giving you order, but it is not like that. It is just my suggestion. I will tell you how to improve our condition in lab. That is necessary anyway. So its definition wise, if we say that green chemistry is an essential part of chemistry curriculum, the teaching of green chemistry in classroom laboratory should go simultaneously. We have to teach in class, we have to work in laboratory green way. In India, although green chemistry is being taught in a few colleges and universities, not all colleges, and some universities and colleges only. Laboratory experiment remain largely the same as being taught 50 years back. I will tell you some of the things what is happening. Still we are working same thing 50 years back. We are doing that thing, same thing we are doing today. Many of the experiment, particularly involving toxic chemicals like liquid bromine, potassium cyanide, benzene, carbon tetrachloride, are not at all safe to human health. I am telling the fact is that liquid bromine, when I had been in the director of pharmaceutical science, someone break the liquid bromine bottles and his hand burned. Now university giving compensation to that person. I'm telling this thing. This is the situation is that till you are using liquid bromine, potassium cyanide also not we are using nowadays. Benzene also you are using. Havoc we are using. Carbon tetrachloride also using. Let's see some of the chemicals I have given here. So green laboratory experiment is necessary for ours in academic community. What is this definition of the green chemistry? The green chemistry is the utilization of a set of principles that reduced only, eliminate is not possible, that's true. Use and generation of hazardous substances in the design and manufacture and application of chemical products. So green chemistry, that is waste minimization at source, use of catalyst in place of reagent. Most of the time we are still using reagent, rather you are using catalyst. Using non-toxic reagent, mostly organic, chemical are toxic. We have to use some non-toxic reagent in our laboratory. Use of renewable resources, also we'll see. Improve atom efficiency means jitne atom leke reactant and product should be the same atom. That should not be any waste product, that should not be any byproduct. Use of solvent-free or recyclable environmentally benign solvent system. Solvent-free is not possible, agree, but we have to use the green solvent. If it is not possible, then the solvent, waste solvent, you have to recycle. That is environmentally benign. So what is the things is that green chemistry, that is reducing the waste product, minimum material we have to use, it should not be hazards that we have to reduce through green chemistry, and risk factor is also very important. When we will work with green chemistry, risk factor will be reduced. Energy also, green chemistry if we study, green chemistry if we use in lab, the energy consumption jo hoga, that will be reduced, and cost also automatically reduce. Why do we need green chemistry? So chemistry that we know, it is a prominent part of our daily life. Chemical development also bring new environmental problems, harmful, unexpected side effects, which result in the need for greener chemical products. So you see how much the chemical product that is environmental problem, then harmful effect, we have to produce, we need some greener solvent. We have to produce some greener chemical. So famous example is the pesticide DDT, that is also not using nowadays anyway. Green chemistry looks at pollution prevention at the molecular scale, is extremely important area of chemistry due to the importance of chemistry in our world today and the implication it can show on our environment. So green chemistry, some program that support the invention of more environmentally friendly chemical process, which reduce, even eliminate the generation of hazardous substances. So we have to apply the green chemistry in chemical process that will reduce that, even possible to eliminate, if possible to eliminate the generation of hazardous substances. That we know very much. Everybody knows that is the green chemistry based on 12 principles. Briefly, I will tell you. It is better to prevent waste than to treat and clean up waste after it is formed. So you see, if it is waste product, if it is not formed, that is better. If waste product formed, then we have to treat it, then we have to clean up. That we generally don't do this. Then another thing is that synthetic method we have to use, in the sense designed to maximize the incorporation of all material used in the process in the final product. So we have to use in such a way minimum materials we can get the final product. And whenever practical, synthetic methodology should be designed to generate substance that poses little or no toxicity to human health and the environment. So we have to adapt some synthetic method in our lab. so that that is not be environmental problem, human health problems. Chemical product should be designed to preserve efficacy of function that reduce toxicity. That means we have to use the chemical product that will function only and reduce the toxicity. And another thing is also used in organic chemistry lab, the use of auxiliary substances that use solvent, PET ether, ether, everything, methanol, ethanol we are used, and separation agent should be unnecessarily we have to avoid whenever possible. And solvent we have to use, that solvent must be harmless when used. Energy requirements should be recognized for their environmental economic impact. So we have to consider the energy also, that also economic impact also that we have to minimize. So synthetic methods should be conducted at room temperature, ambient conditions. Raw material feed stocks should be renewable rather than depleting. That I told you. We have to, byproducts should be renewable. We can reuse that one, and not as that byproduct should be deplete, but we have to do that byproduct raw material feedstock should be renewable, and whenever technically possible or economically practical. Unnecessary derivation that we do in lab, blocking group, protection, deprotection, temporary modification of physical chemical process should be avoided. Unnecessary derivation, whenever possible, that we do in lab. Catalytic reagents, I am telling, is more superior than the stoichiometric reagent. That is, we use sometimes reagent in the acid we use. That is, reagent is the optimum amount or ratio we use in our lab. The reaction positive to completion, and all of the reagent must consume. So rather we use catalytic reagents. That is more important than the stoichiometric reagents. Another things, chemical products should be designed so that at the end of their function, they do not persist in the environment, break down into harmless degradation product. I'm telling that byproduct, what you do, most of the lab, in our lab, we throw it in the dustbin or we throw it in the basin itself. So we have to think there should not be any byproduct persist in the environment. Then it will go to the drainage and it will, environmental issue will come. So that's why I'm telling chemical products should be designed so that at the end of their function, they do not persist in the environment. Analytical methodology need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. So we have to develop our methodology so that during the process technology, there should not be any formation of byproduct that must not be hazardous substance. If it is byproduct, there should not be any hazardous. That should not be any hazardous. Another things, what we do in current practice, simple, some of the chemicals I'm giving, there are a lot of chemicals in organic chemistry, with both chemicals are still we are using in our lab. So this is methylene chloride, benzene, toluene, THF, ether, PET ether, and polychloroethylene, dichlorine, acetone. We are still using huge amount in our lab. All these chemicals is volatiles. All these chemicals are hazardous. What are the alternate? Let's see. This is the situation is that let's see. This is the manufacture, then distribution, then use, then disposal. At disposal stage, if it is recycled, then it go. But if it is burned, incineration, then you can get the energy. That is good. But if it is disposal is go to the environment, that will persist, then problems. Environmental, if it is biodegradable, then it is okay. So this is the situation is that petrochemical industries or renewable sources, extraction, distribution, use, disposal, then environment, then persistence. If it is biodegradable, that is okay. If it is, we do incineration, then you can get the energy. Waste product we can use for incineration, for energy productions. So this is the things is that this is the life cycle flow of solvent we use in most of the industries. What do these solvent end up? This is the situation in India. Most of the textile industry, most of the rubber industry, they are doing this job. Even in Delhi, I'm telling in Jamuna, situation is horrible. This is there due to lockdown. If you see the situation change, Ganga river water pollution totally changed 50%. So this is the due to the industrial belt situation at the catchment area or bank of Ganga. So there are three clean solvent. My suggestion is that three clean solvent. Let's see what are these. One is supercritical carbon dioxide. That is boiling point is low. Polarity is low. It is a lipophilic compounds, non-polar solvent. Another solvent, green solvent, is ionic liquid. Nowadays, ionic liquid is very, very significant for green solvents because that characteristic is very good in ionic liquids. But let's see high boiling point, nearly 300 degree above. That is good also. Low vapor pressures. Polarity is high, aprotics. Non-polar, polar compound, polar solvent, water may not be solubles, but soluble some of the cases, ionic liquid, water solubles, some ionic liquids. These are the solvent we are working in our research field. I'm telling this thing, only the green solvent, ionic liquid we are working. And now another thing is aqueous media, that is water. Boiling point is 100. Polarity is very high, 78, protic also, and hydrophilic solvent, polar solvent. These are the three green solvent, but with these three solvent is sufficient. Let's see. Another thing is if you can find a way to use no solvent at all, that may even be better. That is not possible. That I told you, we can reduce the environmental problem, but we cannot eliminate. That I told you before. So let's come next slide. How green is my solvent? Just because the solvent is non-toxic, that does not mean that is a green solvent. Okay. So if it is energy also consideration, we have to consider recycling of solvent also you have to consider, solubility of solute also consider, toxicity of any byproduct and product separations. So this is very, very important. Solvent is non-toxic. We cannot say it is a green process, but we have to consider these are the 5 things. Another things. What is the greenest solvent? There, it depends on the application it is being used for. One of the main issue is removing solvent from solute. What we do? Mostly क्या करते हैं हम लोग? What do we do? Solute solvent लेते, then application part. And application part we can get the product, and that is the solvent is the byproduct. That byproduct, if we throw it, hello, that byproduct solvent, if we throw it to the environment, if the solvent is toxic, then you see the problem, how problem comes. But it is better, if it is possible, to recycle it. That byproduct solvent we can recycle. But that is also, if we recycle means we have to consider also energy and efficiency importance also. it is viable or not. That is also very important. So if it is recycle it, again solvent to use कर सकता, then we can use it, the solute, then again apply, then you can get the product. That is recyclable is better rather throw it to the environment. Is the source sustainable? First, we have to consider where does it come from? Is the source sustainable? Where will it end up? And how can its effect be neutralized? That we have to think. Is it possible to that? Where it's end up and the solvent can be neutralized? That is the green solvent that I told you earlier. Supercritical fluids, ionic liquid, water, abundant water there. If it is solvent water use करेंगे तो then it is better. And perfluorinated hydrocarbon cleaning agent that you use, or either no solvent at all. But supercritical fluid, I am telling this thing problem. This is the supercritical fluids. That is a substance become a supercritical fluid above its critical point of temperature. This is that critical point of temperature. This is because it is very difficult to prepare supercritical fluid. We have to consider the cost. We have to consider the availability. So it's not so easy to prepare the supercritical fluid, although it is a green solvent for particular purpose, for particular case, that possible, but not for larger scale, because cost effective is very important. Also, not only it is not very stable fluid. So this is not so easy to get the green solvent as a supercritical fluid. But that is supercritical fluid has a good characteristics. What is this? That increase mass transport. That is very good. Gases are totally miscible. That is also very good. No surface tension. Good one. Excellent for infusion extractions. Also possess good. Inert, non-toxic. That is very good. And inexpensive fluid, of course, and environmentally compatible is good, and solvent is tunable with pressure. You can change the pressure, solvent can, properties, solvent can change. So this is the characteristics of the solvent. Most of the characteristics are good so that we can use supercritical fluid as a green solvent, but preparation is not so easy. It is a tedious one. Another one, molecular solvent, water. It is abundant, ultimate solvent, clean, cheap. That is good one. Problem is that water, we cannot use water all time as a solvent because poor solubility of non-polar substance, surfactant or emulsion, they are not soluble in waters. But if you want to work with surfactants, then if it is not soluble in waters, then how we can work that things. That's the problems. So this is the things is that poor solubility for non-polar solute, surfactant, emulsion must be returned to the water course. Water course, pollution possible. Water, if you work with the water, then you take the waste product of water, contaminate with some chemicals, then you throw it to the environment, then it is a pollution problems. Another things, separation often energy intensive. So because water boiling point is 100, so you have to give energy for evaporation, separation ke liye, long drying time is also. So this is time consuming, first of all. Secondly, in cost wise, energy, we say energy consumption is very high. This is not, cost is very high. So it's not so easy to use water as a solvent. Because separation may water, you have to give more energy to for evaporations. So another things, molecular solvent, organic. Another things, dissolve a wide range of solute depending on dielectric constant. If it is dielectric constant is very high, then most of the solute can dissolve. That's why it's good one. And volatile solvent, if it is because water is not so volatile, 100-degree temperatures. So if it is a volatile solvent, if we go ethanol, it is near 60, 65. Then in that case, less energy is required for product separation, for evaporation. Less energy is sufficient. So that's why volatile solvents are less energy intensive for product separation. And organic solvent, that is toxic, that's very, very important word, and generally expensive also. And most of the organic solvent is flammable also. So you see the situation is that molecular solvent only, that is 2 point is better. Dietary constant, if it is high, then it is okay. You can dissolve most of the solute. And less energy solvent, you can use for the product separation because it can evaporate very early. Another things, some of the guidelines I am giving to you, green guideline for teachers, students, and laboratory, what we do in the lab practically. This is my suggestion to all of you, because problem is that I told you before, 50 years back, those syllabus we are still using little bit moderate, little bit change it, but that mental setup we have to change. We will do these things. That is very, very important. Nobody wants to change the syllabus. Nobody wants to change. Jo high, it should continue longer. But question is that that is the policy matter. I agree with you that. Let's see recent education policy how much it can help to us. Because this is the very important part I'm telling these things. First I'm telling experiment should involve the use of alternative reagent which are not only eco-friendly but also easily available anywhere in the country in bulk quantities at very cheap price. This is very, very important. Like that, this should not preferably involve the use of organic solvent, because most of the cases in research or in lab, UG lab or PG lab, we use PET ether. We are using organic solvent. This is not good solvent. Instead of that, we can use ethanol, methanol. It is preferable to use, if possible, ethanol, methanol. That is modified experiments, if possible, should not involve sophisticated instrumentation technique like high pressure system, evacuated system, inert atmosphere like argon. If we go to the rural area, this is in view of the stagnant situation in many of the laboratories, most of the institutions of our country, especially in rural area. It is very difficult. Vacuum pump by inert atmosphere argon, high pressure system, where to get in some laboratory in rural area. It's not possible. You can get urban area, that's true, but you cannot get it. इसलिए ये सब experiment है, we have to modify. जहाँ high pressure system is required or evacuated system required or inert atmosphere required, you have to change, you have to modify that experiment. So sophisticated instrumentation technique we have to try to avoid, and for this we have to modify that experiment where evacuated system inert atmosphere does not require. So we have to think about that things, because most of the colleges, rural area, that is not possible to procure of all these things. So we have to think that things. Second, experiment should avoid tedious experimental procedure, means longer reaction time, reaction at high temperature. You see, longer reaction time means time consuming. Reaction at high temperature, energy consumption is also there. So, and also tedious process. So longer reaction time, एक step में product बन जाएंगे. Why you should go for the 3 or 4 more step? If the reaction take place at low temperature, and why we should at room temperature rather, if I can say, then why should I go for the high temperature reactions? So we have to avoid such type of tedious experimental procedure, longer lifetime and high temperature reaction required. Another things, all organic chemistry experiment, if we say, the person who are working in organic chemistry lab, who are the teachers of the organic chemistry, these are the suggestion I'm telling. First is preparation, separation of mixture of compound, identification of functional group, etc. Because I am physical chemistry background, I am telling these things. That's why I'm afraid to say more things to the inorganic organic people, but we are safe as a physical chemistry. I will tell you why we are safe in lab. Or organic chemistry experiment, what we do, still we are doing in undergraduate or UG level or PG level, preparation, separation of mixture of compound, identification of functional group should preferably be conducted in semi-micro or micro scale. Semi-micro scale means you can use TLC, some micro amount of materials compound is required, or you can go to the UV IR, or is not possible, but UV is possible. But you see very dilute solution you can do for UV IR. So micro scale में काम कर सकता है if you use the TLC, if you use the UV, if you use the IR. So should be method of choice for determining purity, functional group, and structure elucidation. So you see the situation. We have to use, we have to conduct in semi-micro, micro scale. Okay, all organic chemistry experiments. Another things, one can use ethyl chloroformate. Ethyl chloroformate we can use in our lab. Instead of PCl3, PCl5, use of chlorinated compound. It is not good chlorinated compound to use in lab. Okay, so try to use ethyl chloroformate as a substitute for chlorinated compounds, because chlorinated compound is not good. Another things, dimethyl carbonate may be used as a substitute, a suitable substitute for dimethyl sulfate, methyl halide, more methylations. Because if we use dimethyl carbonate for methylations, because the end product will be carbon dioxide, simple compound, simple carbon dioxide. So instead of using the dimethyl sulfate or methyl halide for methylation, better to use dimethyl carbonate. Think about that. That is depend upon the experimental, of course. Try to use, if 10 experiments in your lab, then one experiment if we do with dimethyl carbonate, that is better. So that is the things we have to find the suitable substitute for methylations. This thing. There is another thing, preparation of derivative on large scale, assessing them could be dispensed with. What we do, functional group identification के लिए organic lab, they prepare the derivative in large scale. If you prepare the derivative for the 10 grams, why necessary for 10 grams? If it is 0.1 gram or 1 gram, that's sufficient for assessing. That's why, but it is better what you do. What I can say, the student may be asked to report TLC behavior of the compound PPR. So TLC behavior can be possible better than to prepare the derivative in the larger scale. जो derivative बन गया, what we do? We throw it in the dustbin or to the basin. So not necessary, better to ask the student, report the TLC behavior of the compound. Another things, if we say organic, this is all organic chemistry related. If we go to the inorganic chemistry or inorganic analysis, what is happening in inorganic lab? I'm telling very unfortunate to say in organic lab, even we like people, very difficult to enter in our PG lab. I'm telling in PG, I'm in university in PG lab. It is very difficult to enter in the lab, but I don't know, even student, teacher, how they suffer. So condition of the laboratories for doing inorganic analysis by conventional method in the undergraduate level are at all not eco-friendly. Why? The gases are toxic, causing health hazard. Some students also in our lab, in organic lab, they faint long back. So we have to take hard, like you to the medical house. So this is the thing is that gases are toxic, causing health hazards. Another thing is that insufficiency of exhaust fan remain a big problem. I'm telling sometimes if say exhaust working or not working, that is the technical person will come 10 days or 15 days, this is not working. One session is over, even that exhaust fan not working. So this is a big issue, big problem. I'm telling that. So it is very difficult to repair or replace the exhaust fan if it does not work. So we have to think that it does work. Sometimes I'm telling experiments are carried out in closed door. If you see the ventilation system, if you see the lab in interior area, that is a closed room. And closed room experiment lab is also closed. One door only. That should be two doors, exit and inlay, inside. So that should be, but one inside, जाने के door है, but exit no door, no window too much. So that is also experiment carried out in closed door in hot, humid condition. You see, I'm very unfortunate to say this thing. We had been in the some of the lab in Kurukshetra University in undergraduate levels. Very difficult to enter into the lab when the students are work in the lab. But there is no over ventilation, there is no exhaust fan, sometimes not high, but not working. And space, if we say inside the space, maybe space is 10 students, 20 students are working in lab. So this is that is infrastructure problem also. Lab are also not properly ventilized also. So these are the things we have to think. Even acid fume, you see most of the inorganic acid used, what we say, which are toxic, pollute the atmosphere. So these are the things we have to change our outlook. We have to change our mental setup. We have to be very serious about that things. Before constructing a lab, we have to think about that things. We take care of the things. That is my suggestion to all of you to take care, to do these things. And what is inorganic analysis? Mainly deals with the detection and estimation of basic and acid radicals. For the detection of radical, I'm telling what can possible to do, that is the spot test. That is very, very good one. If we introduce the spot test, that is better one. Small amount of chemicals is necessary, small amount of reagent required, and are not costly. But spot reagent are costly, but it is also cost effective. I'm telling these things. So you have to use some of the things. Spot test is better one to go for the analysis of the inorganic mixtures. Another things, how to improve, my suggestion that I told you, search green solvent for the future is not like that. This is a suggestion how to improve our laboratory conditions. You see the still today use S2S, gives apparatus में यूज करते हैं। मैंने किसी लैब विजिट किया था गुजरात में, तो देखा they have put the KIPS apparatus, new lab they set up of law, very good one. They set up the skip apparatus outside the lab, and they have put the pipes, from the pipes they have put the fume hood, and inside the fume hood students are using. So H2S gas directly not coming to the lab. It is prepared in the outside the lab. They have put the pipe lines, and this is a good one. So, and as H2S is very toxic, I'm telling these things. So it is not good one to use direct use of H2S. So in that case, there is no alternate. I agree with you. There is no alternate in inorganic estimation of basic and acid radicals. So what you can do, that is the suggestion is in a film cupboard in absence of in open air. So that is good one, and be dissolved in water. आप क्या कर सकता है, H2S you can dissolve in water, and saturated solution of H2S is to be prepared and kept in airtight bottles. This H2S water is to be supplied in dropping bottles and be used when required. So you can use that way. You cannot keep it in open air. So that is the alternate way we can think. But better, what I can suggest, better alternative for H2S in inorganic group analysis, highly desirable. So efforts should continue for N1. So this is another things I am telling. We have to alternate. सोचना चाहिए क्या आगे होगा. Another things, you see the situation laboratory remains filled up with acid fume. Rampant use of concentrated acid, nitric acid, HCl must be avoided. Okay. If not possible, let's see. Ammonia bottle must always remain tightly corked. Chemical test using concentrated acid or ammonia must be carried out in fume cupboard. But most of the UZ lab, if you see, this is not doing that things. Fume cupboard to hota hi nahi sometimes in lab. They hona chahiye. This is very, very, very important. I'm telling things. At least one lab, one fume cupboard is very, very important. So gases from the exhaust may be passed through alkali solution. Sometimes if it gas come out, that we can pass it through the alkali solution, lime water for absorption. So nitrite, nitrate salt of calcium may be used as fertilizer anyway. Laboratory must be provided with sufficient number of exhaust fans. Same thing, I'm telling this thing. This is the laboratory condition in our country. So we have to improve it. And my suggestion to all of you, be serious, do something, how to improve the laboratory condition or laboratory atmosphere. Another things, what we do, dissolution of ore alloy for making solution of quantitative analysis must be carried out in a modified fume cupboard. जो inorganic analysis ore करते हैं, that quantitative analysis that must be carried out in the fume cupboard. Another things, very important, I'm telling, fire extinguisher, first aid kit, ice shower should be kept ready in a particular place, but we don't care. Even that, I'm telling, fire extinguishers must be there. Hand gloves, safety gloves, apron must be made compulsory during lab work. So even physical student, we generally in our lab, this is little bit better one in safety point of view. They use also hand gloves, sometimes apron also, fire extinguisher also. Every year they check it. First aid kit also there, or eyes are not that way. That's why I'm telling, some of the thing you can adjust at least if it is possible. So this is the things is that we have to take care of all these things.
how to improve the green atmosphere, how to improve the atmosphere guy green ways. Another thing, spot test must be introduced for the detection of basic acidic anomalous that I told you before. This is very, very significant to do spot test. Another things, preliminary experiment leading to the detection of nitrite, nitrate, bromide, chloride should be carried in the test tube fitted with the outlet bent tube, and gases issuing out of the tube must passes through the alkali solution. We generally don't do this thing. I agree with you, but it you have to set up. If it is a set up in the lab, then it is easy to do that. Anyway, now we are coming. That's a very important things. That is what you do. Test with mercury. You see, test with mercury, arsenic, cadmium, lead, bismuth. But all these are basic radicals, cation high, are toxic. You see the mercury. I don't know in our syllabus still it is there in undergraduate or not. I don't know. Even that some of the colleges may be mercury, arsenic, cadmium, lead, bismuth. These are highly toxic. That's why I'm telling must be excluded from syllabus from undergraduate general stream student. But these tests may be kept for the honor student for demonstration only. Okay. For these metal ions, spot tests are only recommended. Okay. This is simple one. The waste after the test, what we do, if we mercury, if we throw it, arsenic, if we throw it to the open air. So we don't do this thing. We don't do this thing. The waste after the test may be dumped in pits, specially designed for waste disposal place. आप रख दो. आजकल क्या करते हैं? Plant, some of the plant absorb the heavy metals, are seeded or transplanted into metal polluted soil, and are cultivated using established practice. If it is possible, that is. And as they become saturated with the metal contaminant, roots and whole plant are harvested for disposal. Some of the plant they take it, cadmium, chromium, copper, nickel, lead, zinc, sunflowers. I'm telling, if we seed sunflowers in that place, metal polluted soil, containing lead, uranium, cesium, strontium, they can take it by the sunflower that can be removed from the soil. So this is a tedious practice, I agree. That's why it is better to avoid, exclude from the undergraduate level, but for demonstration, you can keep it. Physical chemistry, if we say, as a physical chemist, I can say a little bit safe in physical lab. If we say distribution, some of the teacher may be from the physical chemistry background, my suggestion is that carbon tetrachloride benzene distribution experiment we are using till today. I'm telling this, till we are also using. Problem is that that is the mental setup only. Syllabus may, whatever in the syllabus, we do this. This is the things we have to change our mind, so that instead of carbon tetrachloride benzene, we can use toluene butanol, we can use acetic acid butanol. It is more safer chemicals than benzene carbon tetrachlorides. So these things, distribution experiment में हम लोग कर सकते, that we can do. But another thing is that experiment involving conductometry, polarimetry, potentiometry, piezometry, colorimetry, polarigraphy, spectrophotometry require chemical in very low concentrations. I am telling, polarigraphy में you can work 10 to the minus 6 molar, 10 to the power minus 6 molar solution. When you see the how much dilute solutions, even potentiometer 10 to the minus 3, polarimeter or 10 to the minus 3, conductometer 10 to the minus 3 molar solution. Very low concentration we can work in experiment, have no negative influence on the health or environment. So these experiments may not need any change or alterations. So very dilute solution we are using. If we go to the electrokinetic methods, if we go to the polarigraphy that I told you, 10 to the minus 6 molar solution, very, very dilute solution you can use. That has no influence on the environment. If possible, instrumental method may be introduced from the use level. Better to use instrumental technique rather than the others way if you do it. Another things, general comment. Green chemistry experiment are introduced not to drastically replace the conventional one. Rather, they are considered complementary to the existing protocols. I'm telling, it's difficult to existing जो experiment है उसको drastically change करना, drastically replace करना is very difficult task. So we can do slowly. We can introduce some of the things. जैसे physical में बता सकता हूँ, that is the benzene, carbon tetrachloride, we have to replace it. This is very, very important. This not only provide wider view of various techniques, but also absorb inquest in innovative mind for future development and growth of the subject in general with due emphasis to green chemistry contest. So teacher may take periodical tests to judge understanding of the student about the experimental practice. Whenever possible, feasible, the conventional process should be replaced. Once again, I'm telling, wherever possible, feasible, conventional process should be replaced with the greener one. So this is very, very important. We cannot drastically replace the conventional one. We can replace with the greener one slowly. So let's come, major use of green chemistry. This is very, very, because simply I'm telling, that is energy, global change, resource depletion, food supply, toxic in the environment. What is the use of green chemistry in energy part? What is the use of green chemistry in global change? Let's see one by one. That is the energy, green chemistry क्या काम आ जाता. The vast majority of the energy generated in the world today is from non-renewable sources. Okay, I'm telling this thing, this is a big issue nowadays that damage the environment. Okay, then carbon dioxide produced, even coal, sulfur dioxide, depletion of ozone layers, effect of mining, drilling, toxic, everything. So non-renewable sources, most of the energy are generated, 60%, I think so nowadays. But present government is trying to get the renewable energy up to 60%, 2025. So let's see. Another things, green chemistry will be essential in developing the alternative for energy generation. Photovoltaic cell, hydrogen cell, fuel cell, biomass fuels. All our things is that green chemistry, we have to generate energy, not using the non-renewable energy sources. So this is very good one. Continue the path towards energy efficiency with catalysis. Okay, we have to use some catalysis. So energy efficiency बढ़ जाता है. Then product design at the forefront. Product design is also very important. That point I can tell not today. I mean, another slide details product design in the forefronts. How ion liquid, how the green solvent can be used for the catalysis purpose, for the product design purpose. This is a very important topic nowadays.